Hello and welcome to this introduction of geometric thinking. In this video, I will mention why we study geometry and talk a bit about how geometric thinking is understood as well as categorized at different levels using the Van Heel model. Why is it important to study geometry? Well, the ability to think geometrically allows us to reason logically, find connections between ideas, and understand that the world around us consists of geometric objects and concepts. Furthermore, it allows us to develop spatial understanding that is not only relevant in math class, but also in our everyday lives. The Van Heel model is a way of categorizing levels of spatial understanding. Each level contains a set of thought processes and geometric ideas that students comprehend and learn at each stage. These processes are referred to as objects of thought. Objects of thought are developed through calculation and practice until they become products of thought. These products of thought then become the object of thought in the following stage of the Van Heel model. As you can see from the diagram, the 5 levels consist of visualization, analysis, informal deduction, and rigor. In primary education, we are most concerned with the levels 0 through 2. In order to proceed from one level to the next, students must understand the content of the previous level. For example, the object of thought at level 0 is a simple understanding of shapes. Through instruction, this process transforms so that the product of thought is an understanding of the classes of shapes. As such, understanding classes of shapes becomes the object of thought at level 1, which later transforms into a product of thought on understanding the properties of shapes, and so on. In this model, there are also strands or content that the teacher must go through at each level of thinking to help the student progress. These strands are shapes and properties, transformation, location, and visualization. I will come back to these later in the presentation, but for now I will explain the levels of geometric thinking in more detail using the examples from the strand on shapes and properties. Children usually work at the Van Heel level 0 from kindergarten until 2nd grade. At this stage, students work at visualizing different geometric shapes. These should be introduced to the students by allowing them to play with physical objects, molds, as well as drawing different kinds of shapes. At this stage, students tend to define and categorize shapes based on what they look like rather than using mathematical terminology to group them. During grades 3 to 5, children generally transition into level 1 of the Van Heel model. This stage deals with analyzing geometric shapes more deeply. Children at this stage will learn to recognize the figures according to their specific properties, or in other words, they will move from classifying shapes through informal description toward using accurate mathematical names and descriptive terminology such as angles, sides, parallel, perpendicular, and so on. Van Heel level 2 takes place during middle school or grades 6 to 8. At this stage, students form an understanding of the relationships between and amongst different shapes. For example, they would understand that all squares are rectangles, but that not all rectangles are squares. Once again, in comprehensive school, we are only concerned with the levels 0 to 2, so deduction and rigor will not be discussed here. Instead, let's take a step back and talk about geometric content or strands. Because I have used the first strand of shapes and properties in my description of each level of understanding, I will move straight on to the second strand, which is on transformations. Transformations have to do with the changing sides and positions of shapes. At level 0, students should be familiar with the concepts of sides, flips, and turns. They should also become familiar with line and rotational symmetry. At level 1, students should learn about compositions of transformations, or in other words, how one transformation can be followed by another. Additionally, similar figures and proportional reasoning should be introduced. At level 2, students should be able to make connections between these ideas and further develop these ideas with pentominos. Location involves understanding the position of shapes and points on a plane. For example, analyzing paths from point A to point B on a grid map in addition to using coordinate systems. At level 0, students learn the concepts over, under, near, far, between, left, and right. These form the basis for location specification. At level 1, students examine transformations on a coordinate plane And at level 2, students focus on logical reasoning and generalizations with regards to location. For example, slope, Pythagorean theory, and coordinate transitions are examined. Visualization involves being able to create mental images of shapes and imagining their transformations. At level 0, students understand shapes in terms of their physical appearance, and therefore activities must be in the form of physical shapes and drawings. At level 1, students should be able to draw two-dimensional images of three-dimensional figures and build three-dimensional figures from two-dimensional shapes. At level 2, logical reasoning distinguishes this stage from the previous ones, in that teachers could use pentaminos and platonic solids to further challenge this skill. Teaching geometric concepts, teachers must differentiate their methods to meet the needs of various levels of thinkers. This involves utilizing various types of materials, discussing and connecting concepts to real life, and permitting students to use manipulatives. The Van Heel theory can be used to understand the spatial sense and geometric growth of students. Assessment requires the teacher to reflect on the student's development by using the following questions as a guide. Has the student reached the product of thought at each level? Is the student able to formulate a hypothesis on the topic, and are they able to test it? Are they able to explain a concept to a friend, and are they able to use correct terminology? There are a number of manipulatives and drawing exercises which can be utilized to teach and learn geometry. Technology also provides a variety of learning techniques. Using technological applications is a great way to differentiate teaching, and for those students who have challenges with handwriting or drawing, technology can make learning geometry much more appealing. An example of one such application is the GeoGebra program. It is suitable for learners of all levels, and it allows students to use their imagination as well as make and correct mistakes. This program has the potential to make geometry accessible for all and at all times.